Hi, in this video I'd like to take a deeper look into Java methods and also learn some really valuable things about how programming languages think about and manipulate information. To help us do this, I'd like to run an experiment of sorts. And to start that experiment off, I've written us a really basic Java program. At the core of this Java program is the method magic, which is user-defined right down here. When we come across a new Java method, there's three real things we should notice about it. First, we should ask, what are its input values? In the case of our method magic, this method expects only a single integer as input. Then we probably want to ask, what does this method return? In our case, method is marked to return void. Void methods don't actually return any values at all. They simply execute their code and then finish. You'll notice that when we reference magic in our main portion of our program, we don't attempt to store its return value in any location. That is, of course, because there would be no return value to store. And then the third thing to notice about our method, of course, is what does it do? For our method magic, we simply take the value that we've gotten as input and increase that value by 10. What I'd like to ask you to do right now is to take a minute and just look at this program and try and figure out exactly what the program's output will be when we reach this print line statement. The challenging question here is what happens to the value of variable x when we run this line of code here and call our magic method? Does the variable x remain unaffected by passing it as a value to the magic method? Or does the variable x get modified by this line of code in the magic method so that instead of printing out 5, we print out the value 15? To answer this question, we simply have to run our program. And if we do that, we see that we get the value of 5, letting us know that running the magic method did not modify the value of the variable x within the context of our main method. In fact, we'll get the same output if we never run the magic method at all. So what does this tell us? This gives us a very important insight into how Java handles method inputs. To fully understand what's going on here, we need to take a deeper look into how Java variables operate. In front of us is a representation of the information stored by our variable x. That is the variable in the main method of our Java program. You'll notice that this variable has 3 core components, and let's go through them quickly. On the left-hand side, I put this variable's name, which is the keyword that we use to reference it within scope, and a memory location. Our variables point to a memory location, and in this memory location, we store the variable's value. Name and memory location we can think of as being very static. They're not really going to change for this individual variable identifier throughout the course of our program's execution. However, we can freely and often do change the value stored in the variable's referenced memory location. So why is this important? Well, over the course of our program, we're going to have to translate the information stored in our variable x to the information stored in the variable input that our magic method attempted to make use of. If we take a good look at how variables are set up, we quickly see that there's 2 possible ways to go about doing this. First, we can simply create a brand new variable named input with its own unique memory location, and then simply place as the value in that memory location the same value that we found in the memory location referenced by x. If, when we pass the variable x to a method, this is the technique that Java uses to create the variable input, we can say that Java has passed our variable x by value, because only the value is preserved across the creation of the new variable. Another option would be for us to create a brand new variable input, but instead of simply copying the value from the variable x to the variable input, we could cause input to reference the same memory location as x does. This would be called passing the variable x by reference. In this case, because both x and input would share a memory location where they stored their value, modifying the value of the variable input would also modify the value of the variable x. So, given what we've just learned about Java variables, and taking into account that executing the magic method on line 7 does not modify the value of the variable x, we can correctly conclude that Java chooses to pass variables to its methods by value rather than by reference. However, that's not really the end of the story. Or rather, this fact has implications that might not be immediately apparent to us. Were we to rewrite our program so that our magic method took character input or Boolean input, or really any other primitive type, we would see the same behavior that we've been seeing already. We're modifying the value of this input variable within the scope of the magic method does not modify the value of the variable x within the scope of the main method. However, things are not always so simple. To see this, let's create a brand new method. And in its declaration, we'll have it be the same as our existing magic method, but instead of taking a single integer as input, we'll provide it as input an integer array. Remember that our array will be named as a single variable. So all we need to do to let Java know that we'd like to pass an array to the function is inform it that the variable being given is an array of a certain type. You'll also notice that we now have two methods by the name of magic within our program. This is called method overloading, and it's perfectly legitimate to do as long as Java has a way of telling the methods apart. In this case, Java can tell the methods apart because both methods are going to be given different objects as input. One of our magic methods will execute if the input given to the magic call is a single integer. And our new magic method will execute if the input given to the method is an array of integers. Now, let's write a quick for loop so that our new magic method will increment the value of every integer contained within our input array by 10. This is extremely similar to the magic method we wrote originally, except that instead of operating on a single integer, it's going to operate on any number of them. However, something that may appear weird is going to happen when we modify our main method to utilize this new implementation of the magic method. In order to make this happen, we need to make a few quick modifications to our program. Let's change our variable x from an integer to an integer array so that our program will know to utilize the newly written magic method, which runs when we give an integer array as input. We'll also need to modify our print line statement to make use of arrays.toString so that we display the value stored in the array x properly. And we'll import java.util so that Java knows about the arrays library. Now, it's time to ask ourselves another question. This question being, when we run the magic function on an integer array, will we see the same results we saw when we ran the magic function on a single integer value, a primitive type? To answer this question, all we need to do is run our program. And we'll very quickly see that the output, or the final values stored in the array X, are not the same values that we assigned to the array X initially. This lets us know that our magic method is indeed modifying these values. So this is kind of weird. Why would our magic method operate differently depending on if we gave it a single primitive type as input or if we gave it an array of primitive types as input? To answer this question, let's take a look at the variable X when it's declared to be an array of integers as opposed to just a single integer as we had it before. X as an array of integers as opposed to a single primitive type still gets a name and memory location to identify it and a place where it can live. But its value field looks drastically different than it did before. When X was just an integer, we could get away with simply storing an explicit integer value in X's value field. But as an array, X needs to be able to reference a number of different values. That's what makes it a data structure. To make this happen, arrays, and really every other element more complicated than a primitive, points to a location in memory as opposed to a single explicit value. For arrays, all we need to do is point to the 0 index of the array in memory. Then, by following from that index, we can store a number of different values that our variable X knows how to access. So why is this important? Well, let's take a look at what happens when we pass X by value into a method. As we know, when we pass a variable by value, we're telling Java to create a new variable in the context of the method that's going to have its own unique name and memory location. But this new variable, in our case input, takes the value from the old variable as its own. When we were working with primitive types, these values were completely independent. But now, input and X both have the values of the same location in memory. So, while modifying input's value would not change the value of X, modifying the location of memory that input points to does still change that location of memory when X looks at it as well. Are you still with us? If so, congratulations. That's some complicated stuff we just went over. As you become a more experienced programmer, you'll begin to internalize concepts like this, and you won't have to really think about them explicitly when you're writing day-to-day code. For now, though, there's some logic shortcuts we can use to keep from getting too tripped up. Within the context of a method, if we reference an input variable explicitly and then modify that variable, we're going to be modifying only the variable within the context of the function, as we did in our first magic method. But if we have to take an additional step to access the value that we're modifying, as we have to do when we're declaring an indice of an array, then we're probably modifying via a location of memory or by reference. In this instance, we will potentially affect the variable that provided the value for our function variable. Remember, though, that arrays are not magically by reference. If our magic function that took an array simply attempted to set the value of our integer array to a brand new set of integer values with an all new starting memory location, we would see that we are no longer modifying the value of X when we run this function on it. This is because the creation of a new integer array caused us to explicitly change the value of input. After this line of code, input and x no longer share a value anymore. Thank you very much for watching, and I hope you learned something.